So matrix of a linear transformation. So first problem, find the matrix of the linear transformation T from V2R to V2R T of x comma y equal to x comma minus y related to the basis x equal to even comma e2 y equal to 1 comma 1 1 comma minus. Every time in V2 paper ask this question for 6 or 7 marks. So important questions. So first you should write the given data as it is. So t of x comma y is equal to given. So t of x comma y is equal to x comma minus y. So related to the basis. So basis related to the basis x equal to even comma e2. Basis means number of non-zero vectors present in the echelon form of a matrix is called as basis. So b equal to, so basis, so even comma e2. What is even? So 2 cross 2 matrix 1 comma 0 identity element. So second identity element to 0 comma 1. So vector v1 and v2. So v1 is equal to what? 1 comma 0. v2 is equal to what? 0 comma 1. So number of non-zero vectors present in the matrix is called as basis. So v1 equal to 1 comma 0, v2 is equal to 0 comma 1. So next y is equal to 1 comma 1 and 1 comma minus 1. So 1 comma 1 set of a linear combination of elements. So alpha 1 equal to 1 comma 1. So first element. So second element alpha 2 is equal to 1 comma minus 1. So given, so t of x comma y equal to x comma minus y. So b basis, so 1 comma 0 0 comma 1 vector v1 and v2. So y is equal to, so b number of elements present in the basis is called as number of non-zero vectors. So v1 and v2 are the vectors. So alpha 1 alpha 2 are the linear combination of elements. So alpha 1 equal to 1 comma 1, alpha 2 equal to 1 comma minus 1, v1 equal to 1 comma 0, v2 is equal to 0 comma 1. Is it right? First condition is what? First condition is you should find t of v1 and t of v2. T of v1 is equal to t of v1 is equal to what? 1 comma 0. So consider given, so t of x comma y is equal to x comma minus y. So t of 1 comma 0 is equal to what? X equal to 1, y equal to 0. Okay, now putting x equal to 1, y equal to 0, a 1 comma 0. Is it right? T of 1 comma 0 equal to 1 comma 0. So next we should find t of v2. So t of v2 equal to 0 comma 1. So next to t of v2 is equal to what? v2 is equal to what? v2 is equal to 0 comma 1. So 0 comma is equal to, so x equal to 0, so y equal to minus 1. So t of 0 comma 1 equal to 0 comma minus 1. T of 1 comma 0 is equal to 1 comma 0. So t of 1 comma 0 equal to 1 comma 0. Call this equation as 1. So t of 0 comma 1 equal to 0 comma minus 1. So equation 2. Now we have to use these equations to find c1 and c2 value. After that, then you have to take this equation to find c1 dash and c2 dash value. So consider equation 1, t of 1 comma 0 equal to 1 comma 0. We know that v equal to c1 alpha 1 plus c2 alpha 2 linear combinations of vectors. V is equal to what? 1 comma 0. So is equal to c1 into alpha 1. So alpha 1 is equal to what? 1 comma 1 plus c2 into alpha 2 is equal to what? 1 comma minus 1. So 1 comma 0 is equal to, so c1 plus 1 into c2. 1 into c1, so or c1 into 1 c1, 1 into c1 c1 plus 1 into c2 c2 minus 1 into c2 c2. So next to vector addition, c1 plus c2, so comma c1 minus c2 is equal to 1 comma 0. So c1 plus c2 is equal to 1. So c1 minus c2 is equal to 0. So solve this equation. C2 minus C2 gets cancelled. So 2C1 is equal to 1 plus 0 1. So C1 is equal to 1 by 2. So use this equation. So C1 plus C2 is equal to 1. So C1 is equal to what? 1 by 2 plus C2 is equal to 1. So C2 is equal to 1 minus 1 by 2. So 1 minus half is equal to what? 1 minus half is equal to 1 by 2. So C2 is equal to 1 by 2. So V equal to equation 1, T of 1 comma 0 equal to 1 comma 0. So we know that linear combination of vectors C1 alpha 1 C2 alpha 2 V equal to what? 1 comma 0 C1. So alpha 1 is equal to given 1 comma 1. So C2. So alpha 2 is equal to 1 comma minus 1. So 1 comma 0 equal to product multiplication C1 into 1 C1 into 1 C2 into 1 minus 1 into C2. So 1 comma 0 equal to, so C1 plus C2 vector addition C1 minus C2. So C1 plus C2 equal to 1 C1 minus C2 is equal to 0. By using elimination method, C2 minus C2 gets cancelled. C1 plus C1 is equal to 2C1. 1 plus 0 equal to 1. So C1 is equal to, shift this term into right hand side, 1 by 2. Consider equation 1 C1 plus C2 is equal to 1. C1 is equal to 1 by 2. C2 is equal to C2 as it is equal to 1. C2 is equal to 1 minus 1 by 2. So finally C2 is equal to half. So next we have to find C1 dash and C2 dash value. So T of 0 comma 1 equal to 0 comma minus 1. Equation 2. So V equal to C1 alpha 1 plus C2 alpha 2. C1 dash alpha 1 C2 dash alpha 2. So second vector V equal to C1 dash alpha 1 plus C2 dash alpha 2. V equal to what? 0 comma minus 1. So C1 dash as it is, so alpha 1 is equal to what? 1 comma 1. C2 dash as it is, alpha 2 is equal to what? 1 comma minus 1. So 0 comma minus 1 is equal to, so 1 into C1 dash, 1 into C1 dash plus 1 into C2 dash minus 1 into C2 dash. So vector addition 1 C1 dash plus 1 C2 dash, so comma 1 C1 dash plus minus 1 C2 dash is equal to 0 comma minus 1. So 0 is equal to what? 1 into C1 dash plus 1 into C2 dash is equal to 0. 1 into C1 dash minus 1 into C2 dash is equal to minus 1. So 1 into C2 dash gets cancelled. So 1 C1 dash 1 C1 dash 2 C1 dash is equal to 0 minus 1 minus 1. C1 dash is equal to minus 1 divided by 2. So next then we have to find C2 dash. So C1 dash plus 1 C2 dash is equal to 0. So first equation, so C1 dash is equal to what? Minus 1 by 2 plus 1 into C2 dash is equal to 0. Okay, now shift this term into right hand side. 1 C2 dash is equal to 1 by 2. So C2 dash is equal to what? 1 by 2. Therefore, matrix of a linear transformation is equal to C1, C2. So column vectors C1 dash, C2 dash. C1 is equal to what? 1 by 2. C2 is equal to what? 1 by 2. C1 dash is equal to what? 1 by 2 minus 1 by 2. C2 is equal to 1 by 2. Therefore, matrix of a linear transformation is equal to 1 by 2 minus 1 by 2, 1 by 2, comma 1 by 2.